The frame of this chat today is how do we take something as simple as a motor, a tether or a string or a line, and data, speed, force, time, power, and it's linear in nature. How do we just take this objective hardware and have it help support what we're doing, right? So how do we turn this 1080 sprint, which has usually just been one direction at a time, resisted or assisted, and now how do we put it together with multiple phases, multiple turns, in, out, in, changing the lead-in distances, right? These are all just variables that we manipulate. How many phases, how much load, what data are we looking at, and turning this 1080 sprint into the 1080 COD, right? 1080 change of direction. How does it support and help us build and develop, super elite and kind of next level COD? So,
COD, the past, the present, and the future. The future will probably save a little bit to the later in this three-part series. But I'm certainly going to the past a little bit and the present and the evolvement of the metrics that we've been looking at and exploring. So everyone is on the same page. That's what we're trying to accomplish here. So Sophia came up with this lovely paper. It's almost getting to be 10 years ago now. The point is there was a myriad of different tests and they were shorter or long in duration. There was a variable number of turns, and the overall measurement was the how we quantify this performance. And she was calling for, and rightfully so, very specific information, because a lot of these tests were highly correlated with linear sprint. And we didn't really get an insight into change of direction. And then they tried to look at COD deficit, and it was all based upon the lack of continuous data points or measurements. So when we first developed the 1080 sprint, this was one of my ultimate goals with the system, to get into this. And since this is new and we had a sense of where we wanted to go, but nevertheless, we had to do some trial and error in this process. And here is an older film, and the reason why I know this, because this was during COVID, and the only volunteer that I could possibly get was my son, which is quite a bit older these days, I must say. The point is that we had this little swivel, and we turned it around so it was easy to make transitions. And then we used that swivel and we attached around the waist of a subject. And in this particular case, the athlete was running towards and then doing a 180 degree and returning to the starting point. And that led us to start to think about, how do we start this? Because obviously the tether is pulling me in a given direction. So we had to think about what kind of demands am I imposing on the athlete performing this particular task. And then we had to come up with a term to try to actually name these exercises to clean up that so everyone was on the same page, because and I still to date see that used interchangeable, because I think we have to be careful, because an assisted start, that means that we start by running towards the system, the 1080 sprint, and then we turn around and then we go back if it is a 180 degree turn. And that demand is a little bit different than a resisted start, where we start by moving away from the sprint, then turn around and then come back towards the sprint. And I've always said this, and I've been an advocate, and others with me, is that based on the fact that an assisted start would increase the demand on the deceleration, we feel that that one is the better option if you want to challenge that. Because the thing is that with a resisted start, you will in fact unload the deceleration. Because if I'm coming in here, I'm starting and I'm coming in and I'm starting to slow down, there is something pulling me, something extra pulling me in. And then I have to turn around and reaccelerate with that, which is in contrast to a resisted start, which is actually assisting me. Not very much, but that is obviously based upon how much load you put in. but it still will assist me during this phase. So for instance, from a rehab perspective, I might start down here, but on the healthy side, I would certainly start up here. So I just want to clear those things up. And this also turned into the default that we used when we went for validation, and we also looked into reliability. Those were all done with assisted starts. We get these continuous measurements. So here is a modified 505, and this is a, sprint running. So in the software, dotted line means that I'm starting and I'm moving towards the sprint, and I'm coming into the turn, and then I'm moving away from the sprint. So this is an assisted start. And we have these continuous measurements. This is an example of speed as a function of where the athlete is, so it's position. So the first thing that we had to do is make sure that it's valid. So I'm not going to go through all the boring analysis that we did. They're not boring. I find them interesting. But if you want to read all this, and keep in mind, this is also on our homepage. And we try to update everything on our homepage and keep it updated with all the relevant science. And this one is an open access, and you can go and read and how we did it. But in essence, what we did is that we compared velocity to motion capture, meaning and we used marker-based. And we found that it was a valid representation of velocity during change of direction tasks, which means that we checked that box. And then the next thing that we embarked upon was a reliability experiment, just to make sure we understand like how stable is our outcome measurements. Because the thing is that if we have valid measurements, that's nice and all. But if they're not reliable and stable, how can we make inferences about if an athlete has a better performance than someone else, or is in fact improving, or is actually the performance is decreasing? So here we did another tweak, and we did all assisted starts. But in this particular experiment, we also wanted to actually have a different approach speed. We did not manipulate the load here. And this was a discussion that we had at the time. Because do we want to just keep the task consistent and use a modified 505 and then using greater and greater pulling force? We opted against it. And the reason why we opted against it was the fact that we wanted the athlete to self-regulate and not impose something external that could possibly be harmful. And keep in mind, no one had really done this. So we were like, okay, we tested it and we worked with different players. But we wanted to be safe, and then we went back to motor control and motor learning. So it was a self-regulatory kind of approach to it with different approach distances, which allowed us to have the athletes then self-selected how much speed they were willing to assume before they slammed on the brakes and turned around, which in turn was a way of regulating their momentum, coming into the turn. So we used different approach velocities with a consistent 3 kg loading from the sprint, and the speed settings, they were 14 and 14. And that is also something that I tell people, keep them 14, 14, because then you don't have to think about it if you're moving out or you increase the approach distance, which in turn increases the approach speed. You don't have to think about the setting and the fact that the athlete may catch up to the assisted speed set on the sprint. So we got all this data, and then we were like, well, Damien had just come out with with a cool approach where he looked at deceleration. And this paper, goes back a number of years, but we were like right behind, so to speak. And he used the acceleration deceleration ability, the ADA test. And then he divided the deceleration into two different phases. So I've tried to highlight that here. And this data is filtered. I believe it was 1.3 hertz after contacting the manufacturer of the technology that they had used. So we actually kept it consistent. And the way that Damien divided this deceleration was based upon you come in and you're starting to slow down. And then he divided early deceleration based upon top speed. So a 50% reduction, that was the early decel. And from 50 to 0 or low, that was the late deceleration. And if you have velocity and you have the mass, you can calculate all these variables. I'm not going to go through all of them, but they're dealing with time, velocities, acceleration, forces, and power, but also impulse. So he was able to look at different variables through different phases and splitting up that deceleration phase. So we took that and we applied it basically to a COD task. So what we did, but first, before we applied it, we actually had to think about how do we divide our phases, because it's two obvious phases. And in this case, the assisted start, you have an initial acceleration, you come to some sort of Vmax or top speed, and then you slow down, that's your deceleration, and then you have a reacceleration. And we call that one complete cycle. So we divided it into phase 1A and phase 1B. That's the nomenclature we started using then. But within those respective phases, we could add something. And here we're obviously adding complexity. That's for sure. So we took that model from Damien and we coined it early deceleration phase and late deceleration phase and just employed the same methodology onto the COD. And then even further, we divided the reacceleration also into those phases. So in essence, we ended up with many different phases, splitting this up. While at the same time, I think they're coming up, they're hidden behind both Jesse and Matt here. I'll just move this one over just a wee bit. So for all these phases, we can look at time, the distance, the velocity, acceleration, deceleration, the forces. And we looked at that for all the different phases. And it turned into quite some extensive tables, which if you look at this, you see some massive tables. And again, it's published, it's open access, you can find it, it's readily available. And you can find reliability of all these phases and all these metrics. But then, you know, what do we actually then do moving forward? Can we simplify this? So in a more recent study, we said, maybe we should try to simplify these things. Maybe we should look at some, instead of dividing them into too many phases, maybe we should keep it a little simpler. So then we went with a force velocity acceleration metric, tau, which is in essence the time it takes you to get to 63% of your top speed. So it's an acceleration time constant. So we looked at that. Then we looked at another metric, which was based upon Martin and I discussing, like, how is acceleration and deceleration looked on with GPS, and how would it be easy to communicate with football? And when I say football, I mean in the American side of things, that's soccer. So a half a second is commonly used there. So what is the half second with the greatest average acceleration? So we started to maybe keep it a little bit simpler and also be able to translate and be able to use information from different technologies and then compare between. So we looked at that. And then we said, well, splitting deceleration into early and late, it might be easier for us to start a little bit more broader. It might be easier to communicate and also for people to start to implement and use. So from top speed until the turn, we said, let's just call that deceleration. And here you have deceleration time and we have deceleration distance. And then if we're using the same principle as I used for acceleration, let's use the same principle for deceleration, half a second with the greatest average deceleration. And then we looked at all these variables and we looked at which ones were the best and were the most reliable. And we came back with actually I'm just gonna put them up here. This is what we're presenting, and this is what we're looking at today. So it's a very roundabout way of saying the metrics that we currently present with COD are as follows. I'm not saying that this is going to be set in stone or it's going to be like this forever, because it's called evolving and it's called learning and it's called understanding and exploring. So what we're looking at today in our outcome measurements, if you create a COD exercise, we'll give you the phase times, 1A and 1B. And then you might say, well, why 1? Why do you use the number 1? Matt alluded to it in the beginning here, because you can do shuttle runs, you can do repeated, right? So if you do multiple turns, this will turn into 2A, 2B. All right, you're doing more, 3A, 3B. And then you can start to compare and look at how do these things actually change as a function of reps, which is very interesting to me. And it actually sets up very nicely for a beep test. So phase 1A, time and distance, initial acceleration from start to top speed. You can look at time and distance, and you look at max axle. Again, max axle is the time interval, half a second, that has the greatest average acceleration. From top speed to 0, or turning, that's your deceleration. Here you can look at time and distance, but within this interval, the software finds the half a second with the greatest average deceleration. You're turning around and you're coming back, reacceleration here, and max acceleration are calculated on the same half a second interval. You have to be very careful here though, because keep in mind the initial acceleration, if you're doing an assisted start, is assisted, which is different than a reacceleration, and it's also coming after a turn. So these two variables, you can look at them, and there are some interesting things here that we will get back to later in this series. But inherently, they're different just from one single turn. So these are the metrics that we provide you today. So how do we use them, or how do we employ them? We have created some different models and different ways of thinking about it. And some of you might have seen it, or some of you might have read it, but Adam Petway, Daniel Cohen, and Damien Harper, and myself, we did a study on basketball, and we can put different locomotive patterns into it. So here is an example of a lateral shuffle. And there might be people in the audience saying, well, 5 meters is a little bit too long to do a lateral shuffle, because we did a 5 meter, and they will be absolutely right. And that is another example on you live and you learn and you evolve. But these things, nevertheless, allows you, here is an example of a regular 505, allows you to use the same kind of metrics to compare performances. And here is a running locomotive pattern to compare between different locomotive patterns, which simplifies your model and it simplifies your output, and you have a consistency in how it's communicated, which I think is a tremendous benefit. So the vector up here changed. So let's call this sagittal for lack of a better word. The previous one was more frontal or sideways. And then all these metrics, I just got these. I'll go back. So all these metrics can be selected as your KPIs for a specific COD. And then you have to really consider and think about how do you want to use these KPIs, because they're going to be visualized on the screen. And if they're going to be visualized on the screen, who's the audience? Are you trying to motivate the players? Are you trying to look at something that you are comparing to and what's happening? Or is it evolving? So here it's important that you think about who's the audience of what you show as a KPI on your screen, because when they do something, it could be that they're showing a top speed. That is a selected, or the time 1A. or the total distance. In this particular case, it's yardage. And then you have the other metrics being listed on the side. So this is what it's going to look like in your control app. And here's another screenshot. If you're selected the primary one, here's top speed, and you're looking just to get an overview of that run. You're seeing the overview right here, and that's going to be the big number that you see. So going back to this, almost the first slide. Here you see again, it's the myriad of different tests. And here I would like to give a shout out to Michael Davey, because during COVID we were sitting trying to come up with some sort of platform of how these things can we put them into a model, because this becomes kind of chaotic in a sense. And that's when we came up with a model of how to think about these things. I know I went a little bit quickly, so maybe I'll just go back. When you're starting, think about the start condition. You know, is it a static condition? If it is a static condition, is it symmetrical, asymmetrical, or is it rotated? Like what's your start condition that you're going to accelerate out of? Or is it dynamic? Is there a certain entry speed? Is there a split step, false step, what have you? The next component is, which direction am I going? Am I going forward, sideways, backwards, or do I open up and do a rotational movement pattern? And in terms of movement pattern, what kind of locomotive strategy do I select from? Is it a running thing? Is it a side shuffle crossover, or is it some sort of different pattern that you're after? Then you have to decide the transition, which I tried to show in the previous one, where the running was A to P or sagittal, and the side shuffle was frontal, side to side. So the directionality, and here I've included the vertical because, you know, the counter movement jump is a vertical COD, or the drop jump for that matter. It's just a different approach velocity, which is the same as selecting a different approach velocity when you are performing a COD task horizontally. And here I also put turn and parentheses turns, because you can do repeated. And then it's the default nature of us to think about, if I did running coming in, I need to do running coming out. That is not the case. That is certainly not the case, because you can combine locomotive patterns based upon what kind of activity or sport are you looking at? What are you trying to understand and explore and reflect in these assessments? And again, direction is in here. So maybe we should, Jesse, is there anything that you want to chime in with, or
Yeah, I
put
think
some context, some other context?
yeah, I think you kind of summarized the locomotive pattern framework, which I think is a really solid way and a really valid way of not only just copy pasting something you read in research or copy pasting what might be traditional or conventional in a sport, but how do you make it more valid ecologically to your sport? And I think what this framework allows you to do is to go through this process of position and accel, transition, and reaccel to understand and quantify the qualities that you're looking to test. And it's always that balance between sport specificity and then training the physical qualities that underpin the sport as well. And I think this provides a perfect blend for practitioners to be able to say, I work in basketball, maybe a long closeout, for example. We're going to start with one foot in the key with a lateral stance, accelerate it out, close out, and come back. So I think this just provides a really nice layer to, first of all, create your assessments, but then get really rich data sets for those assessments that can facilitate better profiling, understanding what might be a developmental area or a strength, and then facilitating better prescriptions on the back of that too, as opposed to conventional models, which, as Sophia talked about, is more so dependent on just total time. So I think that's a really good point.
Yeah, because I think this serves how you can design and set up your assessment strategy, for sure. But I think maybe the most important one is to reflect on what you're doing. Like, am I just taking a test just because it's stated and written and it's been validated here? Or do I actually really think about the sport at hand and the activity at hand? what are the demands placed on the subject, which is one thing that Martin and I did when we looked at football, because then we had GPS data of attackers pressing. So we used the data from that, and we said, well, they reach these kind of speeds, and then they slam on the brakes. All right, maybe we should have them reach these speeds in the assessment to actually then get a understanding of their ability to do so. And then we looked at a 10-meter approach and a 15-meter approach, and some people say, well, 15, that's a little bit too far, and yeah, that could be a little bit too far, and maybe 10 meters is sufficient. But at least we based that on something that we took from the nature of the game and how the game is played. And we tried to put it in to better understand how were they able to do that. So it's just as much a model for reflection of what your default strategies are. And here, if you look here and you see that, well, I tend to do this all the time. Maybe I should start to think about that and reconsider my strategies, you know? So that's that. I agree with that assessment. And it's not like you're going to test every single possible combination here, because then you would end up doing nothing but testing. So you have to be very careful then. So I think that was about half an hour or so, Matt. Am I wrong or am I right? I'm
That was pretty solid. You should do this for a living.
yeah, no, I'm usually wrong. So well, no, I have plenty of more slides, but I decided to call it quits before we got into acceleration right there. We can chat about it if there are questions that pop up.
Fantastic. So, no, I think that that was a great job going through the background and why you chose certain things, but also I think it's just as valuable to understand why there are not certain things, right? Or, oh, we only have three main metrics. Well, yes, it used to be 10 though. And there's a reason why it's kind of been pared down. So there is a lot of research and a lot of time and a lot of iteration. Or as you
Yeah,
say, live, learn, evolve, you know? So understanding the why or the why not, I think is a super awesome kind of foundation as we get into COD.
yeah, and then we also had like historically, and you still can get it, you're looking at force, and we're looking at power. Sure, you can do that, but we wanted to like bring it down a little bit. An accel and decel, that's a result of the force, you know, that you generate. So, and then you can look at multi-collinearity and all sorts of statistical things, and there's certainly overlapping things here. And one of the reasons also why we ended up with max decel is that we found this one to be predictive of total time, and actually a very strong predictor of total time in this particular test. But moving forward, that's going to be dependent on which kind of test and the length of the test, right? So if you have a 1505, 15-meter approach and 5-meter back out, it might be that other variables play a larger role, but we'll move forward, and we have tons of ideas of how to do that. So there will be more coming for sure. So this is the summary basically of the metrics that we currently provide you. And I think it's important that you understand where they're coming from. And it's very simple for you to visualize this on your sprint. It's basically put them in a belt, set up the course. And here's another thing that some people get confused by. Because if you set up a 5-meter course, you measured it out perfectly. You saw the athlete, they executed it perfectly. The foot was on the line. And then you go back and you look at the number and you see phase 1A. That wasn't 5 meters. That was 4 meters and 72 centimeters. And you say, did I do it wrong? No, you didn't. Because the thing is that the attachment is on the pelvis and the foot is placed outside the pelvis being a proxy of the center of mass is placed outside your center of mass, which means that your center of mass is going to cover a lower distance than your foot did. So that's perfectly normal. And some people get confused by that because they expect to see 5 meters just because they set the 5 meter distance. And that is usually not the case. And I actually use distance as a proxy for technical execution because if they have a lower distance and they completed the task as described or prescribed, they actually had a good trunk lean and they were leaning into the turn and they were actually lowering their center of mass and they were doing a good job. I'm not saying that equates to or equals technical execution, but it's a place where sometimes people get a little confused. So if you do get that, perfectly normal.
Fantastic. So I have three things, one kind of summary comment and two questions that I'll kick to Jesse and Ola. But first is just this live, learn, evolve idea and how you can modify all the different variables, right? From starting position to distance to number of turns to the locomotion pattern to be as sport specific as you kind of want or need. And there's no kind of right or wrong. I know that that leaves it a little bit kind of open ended, but whatever locomotion patterns that you think are the most important, or your sport coach, right, says, "Hey, I need my basketball players to like laterally slide. Like that's the most important thing to be effective in my defensive scheme." Okay, cool. You can do that, right? Or I really like that study how the 1505 matches soccer pressing demands, right? Like in American football, basically every college team, every pro team has some sort of GPS system. So you can say, okay, cool. What are the max deceleration metrics our guys are hitting in games? And is it similar to like Charlie Francis's 95%? For like high intensity running, right? You have to hit 95 plus, at least in speed training. I know it's a little different during practice and stuff. But do you have to hit, 90 plus percent of your max decel in training to kind of, there's so many things that you can do with it, but it is relative to the sport, whether it's the sport data itself or whether it's, conversations with the rest of the coaching staff or whatever it is. So it really is an iterative process. And
And
what's nice
could
as
I
well is all of these metrics are being collected, but there are like the simplest ones that we kind of put out there first. So even if you're, just collecting and testing for a rainy day, like there are all of those metrics that Ola showed.
if I may comment on because if you're looking, say you get your GPS system, keep in mind there are different recordings and ways of calculating this with different technologies. Because if you look at some of the data that we have provided, and you're looking at the magnitude of accel and decel, they might be different than the high accel decel bands that you see at 3.5 meters per second squared, because we're usually looking at 6, 7, 8, 9 meters per second squared. And I've been getting some messages and very good questions, and it's keen and good observations because they're different. And then you have to look at, how are they calculated? What's the criteria for an acceleration? How long does it have to last for it to be counted? And also, what is the resolution of that signal or the recording frequency at which this data is presented? So you're going to find that, and some people do, you're going to find that, well, this might be a little bit different than I'm used to seeing. It's shaped based upon the technology that you use. So don't be alarmed if you're seeing different values. But you have to understand, even though there is like lots of numbers and decimals and everything, and it appears to be very, very accurate, the methodologies and the technology used to obtain those are different.
Mm. Yeah, I always
So that's a
say
very, very
it's even though we are comparing apples to apples, there's still different kinds of apples, right? So a 1080 sprint measured at the
sure.
waist with 3 kgs of assistance is not the same as GPS from a satellite with football pads on, you know? So just take like the comparison with a grain of salt for sure, just to reiterate Ola's point. Um,
Yeah, yeah. And then also like the methodologies. Yeah, go ahead, man. Sorry.
Mhm. Yeah, like how is it we know what max decel is, but how is it collected? What was the context? Yeah, yeah. So to keep this within 45, 50 minutes, we have one question from the chat, some questions that I kind of thought of and put together. But um, so what would be the difference or the reasoning to touch with your outside foot if that's like short of 5 meters versus saying, hey, I want your inside foot to go to the line so you get that true 5 meters. I would say it's just a matter of reliability and picking whatever you want. But just understanding the limitations, or not necessarily a limitation, where yes, the belt is not going to travel a full 5 meters if it is the outside foot. So whatever you
Uh,
pick, do it the same
yeah,
every time.
exactly. It's like, okay, we in the cases that we've done, we chose the outside foot. That was a choice. Um, because they want to get to that mark as quickly as possible. Could it change the behavior if you said inside foot? Certainly. But as long as you are consistent, because we know that either we haven't tested with the inside foot, but based upon the validity and the reliability that we've seen with all of the things that we have done, it's not going to change that. It's going to be a stable finding. And you're just going to see slightly different distances and phase times. So if you're going to compare with maybe some of the published stuff that is out there, it's going to be slightly different. But from an Excel and reaccel perspective, it's going to be pretty close.
So just pick one and keep it consistent. But I would think from an athlete perspective, it's probably
Be con-
simpler, say outside foot, you know?
yeah.
Um, So, speaking of all of the metrics, right? Understand your context and audience, in both of your guys' experience working with, athletes and also high-level performance staffs, is there a certain metric or metrics or type of metric? I would assume athletes is probably a little simpler just to say time. I would assume performance staffs that understand this can kind of get into the weeds. Do you guys have a main metric, one, two, or three, that you find better for athletes versus you find better for communicating with more of the staff in your guys' experience?
I think that, I mean, first of all, and everyone who's kind of worked with me or known me, you guys included, has heard me bang on about making sure that you implement a closed loop process when you're utilizing assessments. So you assess, you profile, you prescribe, and you monitor. And that loop just continues over and over and over again. So when we're creating these assessments, you obviously have the prescription in mind. So between those two steps, you have the profiling. So if we're looking to implement, say, a 505, for example, to assess change of direction performance, Ola touched on a really good point there where we profile the data and we find out that max decel is actually correlated with or associated with the total time. So for me, that's a really strong point to say, okay, if I'm looking at some sort of output metric, total time is still very valid, very useful. But akin to how force plates have evolved and the utilization of those over the past 2 decades, we used to just look at jump height, but now we have all of these strategy metrics underneath that help describe and explain that output. So if total time is your output measure, completely fine. But what are the strategy metrics that underpin that output? And for me, max decel is a really useful tool for that, knowing that it's such an essential part of almost all sports performances or physical outputs. And then for me, top speed is another useful one as well. How does the athlete, or what max speed does the athlete feel ultimately comfortable decelerating from before changing direction? So for me, select an output metric and then a few strategy metrics underneath that help you understand how that output was achieved. Profile those within your team, prescribe off the back of that, and then you monitor using those metrics at the same time.
I think strategy metric is a very nice term. And I agree with those metrics, top speed, and even say, you know what, if you're coaching someone and you say, you know what, I want you to slam a little bit harder on the brakes. Maybe max decel can be used for that, but it could be that I'm just using deceleration distance because it might be easier for that particular person. So that certainly is a strategy metric and it's a coaching metric, and you use that. I want you to slam on your brakes a little bit later, and then you can just point to the numbers. See what I'm talking about? Because the thing is that if you have shorter time and shorter distance, obviously max decel is going to go up, but it may be easier to communicate with the athlete a simpler metric such as distance and time. But I agree with those. I think those would be my kind of four key metrics here. Another one would be if I'm observing that they're really doing well on and as a result of working on the deceleration and they're shortening their time and their distance, and I see the reacceleration suffer, then you might actually go in and actually use that. Like, how are you able to come out of that turn with that demand? So then it could be that I get onto that. The initial acceleration, the max axle there, I would say I would rarely look at, but sometimes it's a metric that I would use to compare and contrast to other tests. Like, how aggressive am I being in attacking this, or am I pacing myself in that initial acceleration? Am I going for it, or am I pacing myself? That could be one question raised that I can get an answer from using that initial acceleration. But strategies, and I think strategy metrics is a really good way of looking at it. What are you trying to accomplish? Is it just assessments, or while training? How do you choose to use this? Because at the end of the day, the test is the exercise and the exercise is the test. That's the slogan that we have. I think training is the name of the game, or invisible monitoring, and then you get all these data and you can dissect and choose to use them how you see fit afterwards. I'm
Yeah, I
sorry, I
think
was word.
no.
word.
I think to summarize, like output is the simplest and the ultimate end goal. Hey, I need you to go from the zero, go touch your outside foot, come back as fast as you possibly can, and then see how they chose to execute that task, right? So I think output and goal and the strategy how they achieve that. And then last kind of question, as this will lead into my last kind of one or two slides, and then I'll bid us all adieu, is is when it comes time to actually collect this data. So there's two things. One, and not to turn this into our chat in 2 weeks, but how do you kind of coach and cue, and then coach and cue, let's say a 505, and then because this is max effort, max decel, super high eccentric forces and stuff, just how you wouldn't do a full out 30-meter FVP on day one, right? You'd want them to build up to those distances and those speeds and things like that. Kind of what is the general kind of on-ramp process or recommendation? So when it comes time to planning it, right? Is there an on-ramp or how do you handle that? And second, how do you kind of coach, cue, and execute kind of when working with the athletes? And that'll be the last question from me.
Sure. 505 is pretty benign in a sense that A, don't start with high loads. Don't start with high external loads. 2 or 3 kg. I've been using 3 kg. So that's number one. Number two is, if you're looking at this particular person, is hovering right around or above 4 meters per second, which is not that great of a speed. It's a speed that you have at the second step after an acceleration in a all-out sprint. So the speed is not that great. The queuing, I like to I just put up the cone and I tell them sprint to the cone and come back. Because I don't, if there's too much emphasis on where they have to place their foot, you get paralysis by analysis. So I like to keep my mouth shut. Sometimes I have a difficult time, as you may know. But I like to keep my instructions as simple as possible. One instruction that I think is very important is, because you may find some that kind of like tapers off at the end here, which is finish through the cone. I want you to go past the cone. That's a very important one, because you see them, they start to like taper off early here. And if you historically, I've looked at ratios, phase 1A and phase 1B, to get a sense of, are you an accelerator, decelerator, like how do you distribute your performance? If they taper off at the end, that whole thing is thrown off. So I want a full effort and I want to see that curve, that acceleration that just keep on rising. Here is just filtered and it goes down a little bit because of a step right prior to. But if we look further, or if we had the recording further on this, this would just progress. So finish past the finish line.
Yeah, I think from a queuing standpoint, it's again, I'll use that same example of the force plates, where CMJs are pretty much they're performed everywhere these days. Everyone's doing it, and I think there's been a number of good research that's come out explaining the impact of outcome with different cues. So I think it's just consistency, consistency, consistency. If you're going to say, you know, run as fast as you can, or to get there and back as quickly as you can, as long as you're consistent, I think always cueing the outcome is the way to go. Queuing strategy gets a little hairy because you want to see the native strategy that they're adopting to achieve that outcome. Now, in training, if you want to address the strategy, now we're talking about manipulating the environment around it, which is what we've been able to do with motorized resistance, to manipulate the external forces or the external loads to then facilitate the strategy that you're looking to train. And that's the prescription piece we'll get into in part 2 and 3 of this series. But I think always queuing the outcome consistently is a pretty fail-safe way of going about it.
I agree with that. Don't say too much. Go from here to there as fast as possible.
Keep it simple, keep it consistent.
Correct.
Simple and keep it consistent. Absolutely.
Odds are if you're on the Zoom, you already know and believe in the value of testing and monitoring and training COD. It's a game changer in sport, et cetera, et cetera. Oh, look, our software does all of this for you, right? So here's a very poorly executed 505 just to show like a visual example. Again, run through the cone. There's a reason I coach and I don't play anymore. But when you're on the tablet, the control app, as we call it, you create a new session, you hit the plus for an exercise, go to public, go to COD, and then it's the first one at the top, right? And make sure that you're always using that one every single time so you can historically pull every time you kind of did that. So you don't have to mess with any settings. We'll get into that next time, but it's already laid out there for you. So